Hey guys, welcome. We are doing our 8.1 video, and if you could actually title the heading 8.1, Adding and Subtracting Polynomials, and our objective, you don't have to write down, is to classify, add, and subtract polynomials. So let's get to it. Need my hand, there we are. Moving down, and let's go right here. So it says, in some cases, you can model a situation with an expression composed of monomials. What is a monomial? Monomial is a real number, a variable, or a product of a real number and variable, and one or more variables with whole numbers. Here are some examples. Go ahead and write all of that down right in here. Okay, starting out with this sentence and those inclusions. So 18 is a monomial, Z is a monomial. A combination of a whole real number and a variable together is a monomial. -4 times x squared is a monomial. And so we're going to talk about what we can do with monomials. And the other thing I want you to write down is right here, the degree. So what is the degree of a monomial? So the degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant is 0, and 0 has no degree. So sometimes you might get no degree. All right, let's continue to move on, adding our vocabulary first, and then we'll do some examples. Okay, we have a monomial, which is one term, but we can also do a polynomial, which is multiple terms together. So a polynomial is a monomial or a sum of monomials. The following polynomial is the sum of the monomials 3x to the fourth, 5x squared, -7x, and 1. And we can find the degree. This would have a degree of 4, degree of 2, degree of 1, and degree of 0. And the polynomial shown above is in standard form. What is standard form? Standard form of a polynomial means that the degree of its monomial terms decreases 4 to 1 from left to right. And the degree of a polynomial is in one variable is the same as the degree of the monomial with the greatest exponent. So in this case, the degree of 3x to the fourth plus x squared minus 7x plus 1 is 4. So that's our degree. So I want you to go ahead and write all this down. Boom and boom. So get that down. If you need to, pause the video. And then last but not least, right down here, this talks about the different types of terms we can have. Monomial 1 term, binomial 2 terms, trinomial 3 terms. Okay, so I want you to go ahead and write that part of the graph down as well. For some examples, we call it constant, linear, quadratic, and then we have a couple more. I'm going to have to move this down because actually that's not the whole chart. So let's try that again. So sorry, this is the whole chart I want you to get. I'm going to get it all. So binomial, trinomial tells me how many terms I have, but then we can also have degrees. So we have linear is 1 degree, quadratic is 2 degrees, and quadratic, and then 3 is cubic, and then 4 we do 4th degree, then 5th degree, 6th degree, 7th. We don't necessarily have special names for those. Okay, let's look at some examples. So you wrote those two things down. Okay, so number 1. What is the degree of each monomial? So the degree of the monomial is going to be the addition of our exponents. Okay, so this is one term, but we have 3 plus 2, so the degree of this is going to be 5. We just do the exponents 3 and 2. 6 doesn't have an exponent, so it doesn't have a degree, so we don't add anything to it via that. Let's look at a second example. So write down the problem. So you're going to write down all of that right there. What is the degree? 6x to the third, y to the second. The degree would be 5. Let's look at another problem. Okay, what's the degree of this? It's a constant, so it's just going to be 0. That's it. Nothing. All right, let's pick up the pace a little bit. Okay, we can actually add and subtract these monomials if they have the same terms. We call it like terms. We've talked about this before, but notice that we have x squared and x squared, and because of that we can add the front number, the coefficient. So we're going to get 8x squared. The x squared and x squared don't add to make x to the fourth or anything like that. It's just this x squared. Okay? Let's take a look at another example. Here we have x to the third y, x to the third y. So we do have the same coefficient, or sorry, same variable there, so we can actually subtract. This is going to be 4 minus, when you don't see a number, there's secretly a 1 there. So it's going to become 3, and we keep x to the third y. We did this with variables basic, but when we have additional variables, it stays the same. All right, so here's our third example. These examples kind of have different parts to them. So here's our third example. Write each polynomial in standard form. What is the name of the polynomial based on its degree and the number of terms? Okay, so that's where we're going to use that little chart to help us out. So first of all, I want to go ahead and put the highest value first. So this has a value of 1. This has a value of 2 for their degree. So when it comes to the degree, we have a value of 1 and a value of 2. So I need to rewrite this with 4x squared in the front and the 3x in the back. So now we're in the correct standard form. And then we want to say, okay, we have how many terms? 2 terms. So we look up on our little chart, and it would be under binomial. Monomial means 1 term. Binomial. And I think I spelled that wrong. Let me put the I and the A in the right place. Binomial. And what's the degree? So the degree of this is going to be the highest degree in here. So it's not 2 plus 1, it's just 2. So when it's 2, we're not going to say 2, but we're actually going to say quadratic. So quadratic is when something is squared. So it's a quadratic binomial is technically what we would call it. A quadratic binomial. Okay? Okay, and last but not least, we can add and subtract monomials, single terms, so we can also do it with polynomials. So this is going to be our last problem. And what we can do is we can take this, what would be a cubic trinomial, because it's 3 terms, it's in standard form. And this is also in standard form, it would be a cubic trinomial. And we can actually go ahead and subtract these. And the way we do it is the first set we just write out. If I can write, let's see, here we go, there we go. And then we distribute the negative. This is very important. We're going to distribute the negative, so it becomes a negative 7x to the third, negative 5x squared, and then it becomes a positive 12. And then what we have to do is identify like terms so we can combine them. So I'm going to take everything with the sign. So those are like terms. X squared and x squared are like terms. And we'll go violet. And a whole number is by itself, has no one to combine with. And just an x, oops, that is supposed to be that. Just an x has nothing to combine with. So some things don't have anything to combine with, so we can't do anything about it. So we're really just adding kind of the monomials together. So we're going to go, let's switch colors here. So let's take care of the highest degree first and then go downward. So x to the third minus 7x to the third, so that's going to be 1 minus 7, so we're going to get a negative 6x to the third. So I've taken care of those terms. Okay, and then we're going to go with x squared as our next term. So negative 3, negative 5, that's going to become a negative 8x squared. So that's gone. And that's gone. And then 5x has no one to combine with, so we just are going to write 5x. And 12 has no one to combine with, so we just write 12. And there we go. Nothing else can be added. And so I went from 2 cubic trinomials, and now I'm at a what would I say? A cubic polynomial. Once you get over 3, we just call it a polynomial. We don't give it a special name. Okay? So this would be a cubic polynomial. Okay? And that's it. Over and out.